Hello everyone, I'm Sean Spalding, and this is the first part of a long tutorial series that will show you how to build your own Zelda-like action RPG from scratch in GameMaker Studio 2. We're going to be covering top-down movement and animation, talking to NPCs, branching dialogue and fulfilling objectives, buying items from a store, fighting monsters, using various unique items, and a whole bunch more. There's a demo available in the description, so you can go ahead and play the thing that we're actually going to make, and you can also use that page to get access to each episode's source code as it releases. This is a beginner to intermediate level tutorial series, and while I will be delivering my usual style of thorough explanations for each piece of code, in order to actually get through this series I won't have time to break down everything. So if you're a total beginner to coding anything at all, I might recommend my complete platformer tutorial series first. Maybe not the whole thing, but at least until you get the hang of things. But as long as you've either coded before in other languages, or you've even a little bit of experience coding in GameMaker, you should be just fine. We're going to be opening up just by setting up our game resolution, bringing in our player sprite, and moving it around the room. Humble beginnings. So let's open GameMaker Studio 2, start a new GML project, and let's get started. So the very first thing I'm going to do in our totally blank project is bring in the sprite for our hero, our player character, Lulu the cat. So I'm going to right click anywhere in the workspace, go to resources and hit create sprite, or you can also press Alt S as you can see. Then I'm going to click import. Now in this folder you can see I actually have all of the assets that I've handmade for this entire series all in one folder. You can download this folder from the video description if you just want to follow along and don't want to spend time making all your own sprites and that kind of thing. I will be explaining kind of how each sprite is set up as I bring them in, so if you do want to make your own artwork, and I highly recommend doing so, you'll be able to follow along there as well. But to speed things up for us throughout the series, I've gone ahead and made all the artwork ahead of time. So if you have these assets available to you, the sprite I'm looking for is called splayer_strip4. Now, if I, before actually bringing this in, if I just right click and hit open and get it kind of in a thing here, you can see this image is a transparent PNG with our four frames all spread evenly apart. And because I've done that, and because I've named it with this _strip4 at the end, GameMaker knows when I bring it in that it's an image made of 4 frames. And you can see it's automatically split it up into 4 frames. Okay. What I'm doing here with the player sprite, and what I'm doing with a lot of our player sprites going forward, is I'm actually containing all 4 directions of movement that we want our player to be able to face. We'll actually be able to move in 8, but animation-wise we're going to stick to 4, because doing 8 directions of movement for every type of animation would take a lot of time and isn't really necessary for what we want to do. So what I'm doing is, for all 4 directions, I'm keeping all the animation for each direction in one sprite, and then we're going to use some code to dynamically play the animation rather than just relying on the sprite framework to play an animation for us. When you're making a top-down game, it's very handy to do something like this, because otherwise you're going to need a separate sprite for up, another sprite for left, right, down, and so on. Okay, so if you can find a way, as we're going to contain all the directions for a given sprite in one sprite, do so. The code for that won't be until quite a bit later, but just so you understand why on earth we've got like 4 directions in one sprite. If you play the animation, he just spins around, but obviously that's not the animation we're actually going to have in the final game. So now we've brought this sprite in, I'm going to give it a name. I'm going to call it splayer. Okay. And so again, if you want to set up your own version of the sprite, you want to make 4 directions for your player character standing idle, starting with facing to the right, then facing up, then facing left, and then facing down, in that order. Okay, it's very important that they are in that order if you make it, and it'll be that same order throughout our player sprites for running, jumping, and all that kind of stuff later on. Okay, it'll be first facing right, then up, then left, then down. It's to do with how directions kind of work in GameMaker. It'll become clearer later on, but that's the order in which you want to do it. Okay. The origin for the sprite, this is always important, is going to be in the bottom center. Okay, that's going to be where our player is considered to actually be in the game world at any point in time. Okay, because even though it's top down, it's also sort of not, because we've got kind of a front-facing view here and a sort of side-facing thing here. Okay, we can still actually see the character. It's more of a 3/4 view, right, rather than strict top-down. So in order to represent that, the origin of where we consider the player to actually be when they're in the game is going to be in the bottom center of the player sprite, okay? Then the other thing we want to set up is the collision mask. We don't want a full like rectangle for the whole thing, so I'm going to go to manual. I want to define this manually, and I'm going to set it to be around this kind of size, okay? Maybe bring it up one there. That looks about right to me, I think. Yeah, so here I've got it at 4 left, right 12, 14 top and bottom 23. I just want kind of a vague square here to represent the area of space we want to be collidable as our player is walking around. Like, our head probably isn't going to count. We could probably even make it like smaller because it's kind of like this sort of area of the player that we're going to want to consider collidable, okay? Adjust as you need to. This feels about right for my particular player sprite. We might come back to adjust it later depending on various other things, but for now this will do fine. So now that we have an image to represent our hero and our player, we can go ahead and close this and create an object which is going to contain all of the logic and interactivity of our player. We're going to name it OPlayer to start with, and then we're going to assign it sprite to match SPlayer. The next thing we're going to do, and get this out of the way nice and early, is set collision mask to not be same as sprite, but to specifically label it as SPlayer. Okay, that's important. You might think, well, what's the difference? Same as sprite would mean that it is SPlayer, right? But what we're going to do throughout the game, we're obviously going to animate our player, is going to change sprite from SPlayer to SPlayer walk or SPlayer roll and various other different things. And what we don't want is for our collision mask to then change with the change in sprite and to have to set up that collision mask to be the same on every single sprite. What we do is just set the collision mask to strictly be SPlayer so that when our sprite changes, our collision mask does not, and it stays as that collision mask that we set up in our sprite. Now, before we get into the events and logic that control the player, let's take a look at our first room. So you should have a room by default called room 0 here. You open that up, you'll just get this big blank rectangle. And we're going to go ahead and change the width and height of the room. I'm going to change mine to 320 by 180. Okay, this is going to be the resolution of the game, 320 by 180, and we're going to use this room to kind of define that. Now, you can use whatever resolution you like. You can use much higher resolution. The reason I'm going for this one is, one, because it's the resolution all my sprites were designed for. This is a tiny 16 by 24 sprite. And also 320 by 180 is a useful resolution as it divides very cleanly into a lot of popular 16 by 9 resolutions. And since it divides evenly into them, you're not going to get any problems when you scale up your pixel art to those most common resolutions. It's very simple. It'll happen automatically. It allows to go full screen very easily and run in a window of various different sizes. All right. So we've set it to 320 by 180 here, but and if I just click on the instances layer, click on OPlayer, and just sort of place in somewhere in the game room, right? And then if I run the game just on this, you can see him spinning around as well, because that the player sprite is obviously animating at the moment. But you probably can't see much at all here, and that's because I actually use a 4K monitor, so this is going to be no good for you following the series. On a 1080p monitor, it might like be a bit bigger and be about this much, and you might be able to see it. But what you might want to do, you definitely want to do this if you're using a 4K monitor, and if you don't, you probably still want to do it just so you can see a bit more, is we're going to stretch the viewport up, okay? So if I go to viewports and cameras and click enable viewports, and then go to viewport 0 and click visible, okay, you'll see we get this white rectangle that showed up that's way bigger than our game room at the moment, and this is the camera that's we're going to set up. So we're going to change the width and height of the camera, of what it can actually see in the game world, to be what our room size is, so 320 by 180, which changes that white rectangle to match. But then in viewport, which is how big it is in the game window, we're going to change width and height to be for me, I'm going to change it to 1280 by 720. If you're following along on 1080p resolution, you might want to use 640 by 360. And I'll show you that now if I run that. You see it's still a bit small for me, but for most people on like a 1080p monitor, that'll be nice and big. But I'm gonna do 1280 by 720, and that's a bit nicer, so we can kind of see what's actually going on. All right. If you are on a 1080p monitor and you use 640 by 360, the size proportionally should kind of match up to what I've got now. It is important to get all this stuff kind of sorted out as early as you can in your project. That's why we're doing it now before we even have any game logic. You know, we're deciding on our resolution and what it's going to be, so we can keep things consistent. So I'm going to close that now, and the other thing we want to do with our resolution very quickly is go to Game Options, come to Windows, and then Graphics. If you tick Allow Full Screen Switching, what this will do is it will enable a shortcut in your game just built into the runner. So if you press Alt and Enter at any point, it will automatically swap to full screen. It's arguable that you might want to do a manual setup of this, but this is more than good enough for our game and what we're going to make, okay? And I'm also going to make sure here in the scaling, it is by default, but just make sure keeps aspect ratio is ticked. Because we're using this resolution, as I say, on most 16:9 monitors, you're not going to have much problem with scaling because we're using a very low resolution that scales nicely to 720 and 1080p and 4K. But if you do put the game on like a 4:3 monitor or something like that, it'll end up producing black bars when you scale up, but it'll stop your art from like stretching and looking weird, okay? If you want to know more about working with different resolutions that aren't 16:9 and how to deal with black bars and resolutions and things like that, there's a very good, I think it's a 2-part series by Pixelated Pope on resolution and aspect ratio management. He goes over everything in a lot of detail. Highly recommend going and checking that out if that's something that interests you for your specific project or your game. But as I say, for what we're doing, just setting this up, ticking this on, and using this specific resolution and keep aspect ratio, allow full screen switching is more than good enough for what we want. So if I run the game now, see our black window here, and if I press Alt Enter, you can see it's given us full screen. And the pixels are nice and clean. They're not like stretched or distorted in any way because it's scaled right up all the way to 4K with no problem, and it would to 1080p as well. So now that was a lot of setup, but I promise you it was very important. But now we can finally go ahead and start writing some actual game code. In fact, if I just close the workspace down just to get rid of everything and click this plus, make a brand new workspace. So it's nice and clean, just a quick way of doing that. And then we'll close the room as well and get rid of that on the side. Open our player object, nice and blank, and click Add Event, add the Create Event, okay? And you'll get an empty code window. Now, most of the time if I'm working in a code window, what I'll want to do first of all is maximize it. I personally make the font nice and big, but that's just more for the benefit of you guys watching the video. Depending on what device you're watching it on, it might be harder for you to see, etc. But you can shrink and increase the font size with F7 and F8 in case you are interested in how I am doing that. All right. There might be some default text here that doesn't match what I've got here, but get rid of anything that's in the code window when you first create it, so it is just totally blank. Okay. The first thing I'm going to type in here is image_speed. You can see that's come up in the autocomplete as well. And when I finish it, it turns green, and set that to 0. That's going to stop us spinning around, okay? Because as I said, we're going to manually handle all of our animations later on. So we're going to turn image speed to 0 so that basically disables the automatic animation of this particular object, okay? Then I'm going to declare a couple more variables. H_speed equals 0, that's going to represent our horizontal speed, and V_speed equals 0, which is going to be our vertical speed at any given time. The only other variable I'm going to define is how fast we are able to move when we want to walk. I'm going to set that to 2 pixels a frame. So I'm going to set speed walk to equal 2.0. It should be stated I have my own naming conventions for variables, and you can use whatever you like, but just try and be consistent, okay? You don't have to use all the variables I use. It'll make it easier, certainly, to follow along with the tutorial, but I have my personal naming conventions. You can use whatever you like. Now, before we go any further, I'll just run that just to demonstrate that image speed 0. As you can see there, it stopped us from animating. Okay. So now we're going to add the step event for the player, which controls everything that happens, every single game step, control the vast majority of our player logic is going to go in there. Now we could go back to the workspace and click add event again, but what I'm going to do is just right click in the code editor, okay, of OPlayer create, just to keep us in full screen, and go to add open event and add the step event, okay? Then that adds the step event. Like if I go back to the workspace, you can see it's in there now. And we're ready to start adding code to that. Just a quicker way to do that for you, okay? Now the first thing we want to do with the player on any given frame is find out what keys the player is actually pressing, okay? So then we can work out what to do with those inputs later, whether we're moving, activating something, attacking, opening the menu, and so on, okay? So we're going to have a whole bunch of variables that store the state of various different keys on our keyboard, okay? So key left, that's going to be about whether or not we're pressing the left arrow key or the A key, as we'll come to in a bit. But for now, just whether or not we're pressing the left arrow key. So I'm going to type keyboard underscore check VK left, okay? Which is obviously going to return true if we're currently pressing the left arrow key and false if we're not, okay? So that's 1 if we're going left, or 0 if we're not pressing the left key. And then very similarly, key right equals keyboard underscore check open bracket VK underscore right close bracket semicolon. Same thing for the right arrow key. Now I'll just quickly do key up and key down. That's exactly the same thing. Okay, remember to end every line of code with a semicolon. GameMaker actually lets you get away with not using semicolons in a lot of places, but please do. It's very good practice to declare the end of a function or a line of code, okay? Oh, and let's fix this here. As you can see, this is blue because I spelt this wrong. There's a handy little spell check for you there. Change that to that. Now I'm going to establish a couple more button presses just for things that won't be used in this episode but will be used later. Just makes sense to get them all in now so we don't have to keep coming back to this part of the step event. Okay, so I'm going to do key activate is going to equal keyboard check pressed. Slightly different function, so keyboard check tells us whether or not the key is currently down or not. Pressed tells us whether or not it was pressed this particular step. Okay, so for key activate, that's going to be when we talk to NPCs, activate objects, pick things up, and so on. That's going to be the space bar. Now I'm going to do just a couple more of these real quick. So I've added key attack in here, which is for attacking things. That's going to be our shift key. We're going to use the control key on the keyboard for activating items, things like the hook shot and the bow that are going to come a lot later in the series, okay? Just getting them in there now. The other thing is, I'm just going to shrink the font a little, so I guess we need some space on the end of these lines. Now, these are all like well-known keys on the keyboard that we can do with VK underscore left, right, and so on. If you want to use individual letters, it works a little bit differently. We have to use what's called the ORD function. So if we say we don't want to use the left arrow key and we want to use A, like for doing WSAD, right? Instead of VK left, I would type ORD, open bracket and close bracket. And in those close brackets, we put 2 quotation marks, okay? And then in between those 2 quotation marks, we put the letter that we want to use, okay? Don't worry too much about that now. That's just how you do it, okay? That's just how you get the letter in relation to the keyboard, okay? As compared to like these VK rights, VK up, it's interchangeable, okay? If you want a letter on the keyboard, that's the function you use. Middle click it to bring up the manual if you want to learn more about it. But that's all you need to know about that for now. The other thing is, well, what if we want to check 2 keys? Well, we can actually do that. We can check, in fact, technically as many keys as we want in one particular variable. What we can do is, because this will just return true or false, what we can do is combine it with another thing that will contain true or false, and we perform a logical OR statement with it. So if I type OR there, you can see it's kind of bolded and gone yellow. And I can put keyboard check OR, and if I just change this one back to VK left, So what an OR does is it returns true if either one of the two functions are true. Okay, and if they both have to be false in order for it to return false. Okay, so if either one of them is true, this will become 1 or true, right? Okay. The other way we can type OR as well, there's two ways to do it. You can either write it like that, or you can write it with two vertical pipes, I believe they're called. Okay. This is where it is on my keyboard. It might be somewhere else on your keyboard, I don't know, but there it is for me. Once you've done that, remember to put a semicolon at the end of here to declare exactly where the end of this particular line of code is. I'm going to do the same thing for right, up, and down. We're going to OR them with their WSAD equivalents. So obviously feel free to pause the video while you go and actually copy those things down, right? Okay, so now that we've got our inputs, we know which keys the player is pressing, which keys the player is not pressing. We can begin to use that to process what to actually do with our player, where we want to move, how we want to behave. Now we're going to do this slightly differently from how we do movement in, say, a platform game where we quite simply move along one axis left and right and every now and again jump. We just sort of handle the two axes fairly independently. We're going to combine our up and down axis with our left and right axis to find a vector of movement. So we're going to work out, by combining, our up and down key and our left and right key, work out what angle we're trying to move at and how far to move in that direction. The reason to do it this way is because if we handle top-down movement, if you think about it like moving on a grid, if you've ever played like a grid-based board game, you might be familiar with the fact that moving diagonally across a grid moves you way faster in a particular direction than moving just horizontally or just vertically. If we were to move 2 up and 2 to the right simultaneously, that combines to a total distance further than what we want our actual maximum speed to be, meaning that you're able to move faster just by moving diagonally. We don't want that, so we're going to do some simple vector stuff to make sure that we're always moving the exact same distance regardless of whether or not we're moving diagonally. Okay, the first thing I'm going to do is use a little clever trick to work out the direction of movement based on all 4 of these keys. So we're going to combine all 4 of these keys together to work out a final direction. So if we're pressing like up and right, we should end up with an angle of 45 degrees. That's assuming 0 degrees is starting from facing to the right. So like 45 degrees would be facing upright, 90 degrees would be facing up, and so on. Okay, we're going to get back an angle. So input direction is what's going to store our angle, and it's going to equal point_direction. That's a function that you can use by plugging 2 coordinates in, and it'll tell you the angle between those 2 coordinates in your room. The room part of it actually doesn't matter for us. We're just going to use the fact that this is a quick way to calculate a direction between 2 different like grid positions, essentially, right? So my first position is actually just going to be 0, 0, just kind of as like a root position. Imagine it as the root position on a graph, okay? And then I'm going to type key right minus key left. Okay, so if key right is 1, it means we're pressing the right arrow key. If key left is 1, we're pressing the left arrow key. So if we're pressing them both, they cancel each other out, because 1 minus 1 is 0. If we're pressing neither, they cancel each other out. 0 minus 0 is 0. But say we're just pressing key right, 1 minus 0 would be 1. So think of that again on a grid, on a graph, sorry, between 0, 0 and 1 on the x-axis. Okay, so that gives us one position to the right. If we're just pressing the left arrow key, it would be 0 minus 1, so we end up with minus 1, so x position of minus 1. Hopefully you can start to see where this is going. If I then put a comma and the second y coordinate I want to put in is key down minus key up. Close bracket, semicolon. Okay, similar thing. So either 1 minus 0 gives us 1 going down, or 0 minus 1 gives us -1, therefore going up. And so say we had -1, -1, we end up with an angle of like 130 degrees, 135, sorry, I can't do maths today. Just a reminder in case, or just to let you know in case you're not aware, angles in GameMaker are always considered 0 degrees facing to the right, and then they circle around all the way back to 360 degrees also facing to the right, okay? So 90 degrees is up, 180 degrees is left, 270 is down, okay? And then that is also why, as we come into our sprite, we can see we've got the sprite organized in that same way, okay? So our first sprite is 0 degrees, then 90, then 180, then 270. All right, and that's why we always start all directions from facing to the right, and we go around anti-clockwise. All right, okay, so we have an angle, but it might be irrelevant if, say, all these like cancel each other out. So say like we're pressing all 4 arrow keys or whatever, right? That might give us an angle of 0 because it's just it would be 0, 0 to 0, 0. There is no angle between that. I'm not actually sure what that returns actually from an angle from one point to the same point, probably 0 degrees. So that wouldn't be relevant. So we need to make sure that the combination of keys we press is actually giving us a valid magnitude in a given direction. Okay, so I'm going to type input magnitude. And then this is simply going to equal true if we want to move in this direction, okay? Or false if we don't actually have a direction to move in. Say we're just pressing the left and right keys simultaneously. And nothing else. They should cancel each other out. Okay, so to do that, I'm gonna basically make this an OR between 2 conditions. The first condition is going to be key right minus key left does not equal 0. Okay, so if key right minus key left is not 0, that means either 1 minus 0, therefore 1, or 0 minus 1, therefore -1. So we're either want to be moving to the left or to the right, but if we combine them both together and it equals 0, they cancel each other out, okay? So assuming that's not 0, it'll come back true. So we do want to move in whatever this direction is, okay? And the same for up and down. So I'm going to do another logical OR here. Open bracket, key down, yeah, that's right, minus key up does not equal 0. Close bracket, semicolon. All right, and then finally, we can actually go about moving the player character. Okay, so I'm going to write a comment here with 2 slashes, turns green, movement, just to label this section. In fact, we can go up to the top here as well and put a comment in. Very good practice as always to comment stuff. Get player input. Okay, get all player inputs. We calculate some stuff based on it. And then we can process that into our player's actual movement. So h speed, that variable we declared in the create event, is going to equal, not 0, well it does equal 0 at the moment, but it's going to equal length _x. Now this is a function that we can plug in a length and direction, which we happen to have. We have a magnitude and a direction right here. And it'll give us back the x component of that vector. Okay, so it'll tell us how far along the x-axis we have to travel to move if we were going to make that particular movement happen. All right, so the length we're going to provide it is input magnitude, which is a 1 or a 0, depending on whether or not we're moving, multiplied by speed walk. Okay, that's our walking speed, which we know is 2 pixels per frame. And then that's the thing you could change if you're holding a button to run or something like that. You could do speed run and so on, right? Okay. And the direction we're going to give it is obviously input direction, that angle that we worked out. All right, and I'm going to do the same again with vertical speed, but instead of length to x, we're going to use length to y, so we're going to get that y component of our movement. Use input magnitude multiplied by speed walk, input direction, again, exact same inputs because it's the same length, same direction, all right? Then, very simply at the bottom, x plus equal h speed, y plus equal v speed. So that's everything. You'll notice, obviously, we have this little warnings still up here that tell us we've only used these variables once. Very handy as you build up the code later on to be able to see back if you've declared any variables you haven't actually used throughout your project. It's because we're only going to use those later on, so again, don't worry about those. Let's run the game now. If I press F5, we see we've got our game window here. He's no longer spinning around as he was before, and if I press up, down, left, right, you can see we can move around, and our diagonals are not moving as faster than if we were just holding one particular direction. Okay, I can do it with the WSAD keys as well. I know you can't see whether or not I'm using the WSAD keys, but trust me, you can use both both sets of keys, and you'll discover that for yourself as you're coding alongside me. That's everything we're going to cover for this episode. As I said, we're starting quite simple. The next steps are going to be animating the character, and then of course handling walls and collisions. This series is almost wholly supported by my patrons over at patreon.com/SeanJS. Those are the names you see passing by now, all lovely people that enable me to do this work and funded its very existence. If you like the work that I do, or you think it's important and helpful for others, please consider supporting me and keeping work like this free and accessible for everyone, as well as getting your name in the credits, regular updates, and behind the scenes source code and goodies. A huge extra special shout out to the following patrons: Arrow Barbarian, Bowser the Dog, Bertie T, Dakadondigo, Dark Rider 0318, Do What Doobie, Ego, Frederick Habedler, Gargoyled Drake, Hare, Hyungjin, James L. Anderson, James Siggins, Jason, Joseph Wetmore, Lemoniskate, Leo, Max M, Owen Morgan, Relentless Rex, Rene Dam, Robert Churches, Rovan Darlin, Run, Rupinder, Scott Matthews, Simeon Yayalulaglo, I'm getting better at that, Stephen Hagen, T. Lesson, Travis Womack, Tyler Hubel, Victor Stewart, Zachary Locke, Zephyr Flame, and Zinan May. You're all wonderful people. All my patrons are wonderful people. Thank you all so much for your support, and thank you for watching this video. Thanks guys. Catch you guys next time.